Okay, so let's go over the questions on page 16 to 20 on your workbook. Alright, so the first part here, so the slope means the velocity, and if the slope was straight, then you're achieving uniform motion. If it's curved, then accelerated motion, and if it's right here, then it's going to be when your speed is 0. Down the bottom here, so when the velocity versus time graph it's slanted like this, then we have acceleration. And the displacement is this area right here, right? So for example, the displacement for this area under, it would be, right, my rise is 10 and my run is 5. We're going to divide by 2. So our displacement is this. Alright, so this is our displacement here, right? Because we have a triangle here. So we got a base times height divided by 2. And right, so the line was straight, then this would be uniform motion. And if it's completely horizontal like this, then there's no acceleration, right? The velocity is constant. Over here, this really important key to the graphing part is that you know these 8 things here, right? So you should have got something along those lines. So, the slope, once again, is either its speed when it's distance versus time, and velocity when it's displacement versus time. And the slope of a speed versus time, it means acceleration. So it's not 0, this means acceleration. Alright, so let's talk about some of these, let's talk about how we related some of these graphs onto these parts here. Right, so this one is C, because once again, it's when it's moving at a constant rate, right? So when the distance versus time graph is standing like this, then it's constant. This one's B, A, B, A, D, and all of these are C, coincidentally, for some weird reason. But if you have a question about this, please email me. Alright, moving on to the next part here. Your answer should have been C, C, A, C. And this one here is a little bit interesting here, right? So it gets you analyzing the graphs, right? So from 2 to 4 seconds, so from here to here, that's when the woman is traveling at 3 meters per second. From 2 to 4 seconds, from 4 to 6 seconds, that's when she's not moving. From 6 to 8 seconds, that's when she's moving again, but at a slower pace, right? So notice that earlier I was saying, right, the steeper it is, the faster you move, right? So from here to here, this was very steep, and from here to here, it is less steep. Last page here. So this page here has us analyzing this graph, right? So from 0 to 4 seconds, so that's from here to here, that's when there's positive acceleration, right? In other words, this going forward. From 4 to 6 seconds, so from here to here, that's when it's uniform motion, right? When there's no acceleration. From 6 to 8 seconds, it's going in the opposite direction, right? So as we're going forwards, then this must mean going backwards. This is from 8 to 10 seconds. That's this point here, right on the horizontal plane. So that's when it stopped, right? That's when the acceleration is 0 and it stopped. right? Whenever it's on the right on the horizontal plane, that's when it stops. Okay, so let's talk about the second graph. Oops. Okay, so from 0 to 2 seconds, in case it's a little hard to see, but it's here. Make that straight for you. From 0 to 2 seconds, that's when, once again, it's flat like this, so that must mean it's uniform motion and there's no acceleration. From 2 to 6 seconds, it's going backwards, right? It's accelerating the opposite direction. And from 6 to 10 seconds, its acceleration is going forwards, like that. This one here, going from 0 to 4 seconds, it's positive slant, so it's a positive slope, so it's going to be accelerating forwards. From 4 to 6 seconds, it's going backwards, accelerating backwards. 6 to 8 seconds is right here. That's when it's uniform motion. From 8 to 10 seconds, it's going forward again, but at a less steeper curve. So this is slower than this one. This is fast, this is slower. Alright, so that wraps up our workbook question from 16 to 20. Once again, I'll be here during class time, as well as reachable via email if you have any further question. Thank you, that's all for now. Bye.